All right, this is station 7. So in the center of your drawing, you've got the number 1. That is the core of the sun. That's where fusion occurs. And fusion is where hydrogen, 2 atoms of hydrogen are smashed together or fused into 1 atom of helium, and there's also a release of energy. And that's happening at number 1 in the core. Number 2 is the radiation zone. This is where the energy from the sun is being radiated out to get to the surface of the sun. Number 3 is the convection zone. So just like in the center of the Earth and just like with the atmosphere, the particles that are in this zone are being heated by the energy from below and are rising, and as they get to the cooler surface, they sink back down and they go back down to collect more energy. So this is how energy is being carried to the surface of the sun, through the radiation or through the convection zone in number 3. Number 4 is the photosphere. It's the outside of the sun, the top layer. That is where a lot of the light is contained. Number 5 is the chromosphere. Number 6 is the corona. The corona is the atmosphere of the sun. And this is where a lot of the sunspot activity and the prominence activity and the solar flare activity occurs. Number 7 is a sunspot, so it's a cooler region in the sun than the rest of the sun, so it appears darker because it is cooler. Number 8 is granulation. When you look at the surface of the sun, you see almost like rippling or granulation in the surface of the sun. Number 9 is a prominence. When you get solar ejection that circles back and creates a large arc like that, it's called a prominence. If it ejects out and it just keeps going, that's a solar flare. If the solar flare is pointed in the direction of the Earth, then it's bad for us and it could cause problems. All right. So then we get to the models of the Earth. You got geocentric, which is where the Earth is the center of the solar system. Everything orbits the Earth. And then you've got heliocentric on the right-hand side, where the sun is the center of the solar system and everything's orbiting the sun. Now, the current accepted view of the solar system is heliocentric, and that's because of a discovery that Galileo made. He created the first telescope. He looked up at Jupiter and he saw 4 moons orbiting Jupiter, and his theory was if there are things that can orbit other planets, then that means that the Earth is not the center of the solar system, and it became the greatest piece of evidence to rejecting the geocentric viewpoint. And the last question on your sheet for this station is the rotation of the sun. The sun rotates or spins once on its axis every 27 days, so a little less than a month to spin once on its axis, whereas an Earth, it rotates once every day. All right, 8th graders, so this is your walkthrough for Station 8 on the Earth, Moon, Sun. This is my model. Here's the Earth. It's half painted black to represent the nighttime side and the daytime side. The daytime side will always be pointed towards the sun, and this one is the moon. So the moon, same thing. Half of it is black, half of it is lit, because the lit side will always be facing the sun. Now, the way that everything is set up now, this is in position 1. The moon is in position 1. So on your paper, if you look, the moon is in the middle of the Earth and the sun. If you were on the Earth and you were looking at the moon, you would be looking at the dark side. You would not see any lit moon. The moon is in new moon phase. This is called new moon phase. All right? Now, incidentally enough, this is the phase that the moon needs to be in order for a solar eclipse to happen. The only way that the moon can cast its shadow across the sun and block it out is during the new moon phase, when the Earth and the sun are on the outside and the moon is in the middle. All right? This does not happen all the time because the moon is slightly tilted and it changes in its eccentricity. So sometimes it's above the sun, sometimes it's below the sun. Occasionally, though, it will go directly in front of the sun and it will block out the sun. That is a solar eclipse. All right, so the only time that a solar eclipse can happen is when the moon is in the middle of the Earth and the sun. And that is always in a new moon phase. So solar eclipses always occur during the new moon phase. All right, This is position 2. I'm going to make sure that I point the lit side of the sun at lit side of the moon at the sun. And if we were on the Earth, you see that little sliver crescent? That's what we would see. That's a waxing crescent. Waxing means it's growing. It's getting bigger every day. All right, so that crescent will get bigger and bigger and bigger every day. If it were decreasing, in other words, when we get over here to position 8, it's going to look the same, but it's going to be waning. It's going to be decreasing back to new moon, but this is growing from new moon all the way out here. When we get to the other side, will be full. All right, so that's what you see when you're on the Earth. You look and you see a crescent moon. So then we keep going. And again, so if you were on the Earth, now you see a half moon. All right, this is first quarter. Then we keep going. Now we're at position 4. And if you were on the moon, or if you were on the Earth, you would see a gibbous moon. Again, this is waxing because it's growing. But a gibbous moon is more than half full, but less than a full moon. All right? And then we continue on to position 5. And now, if you were on the Earth, first of all, the lineup is sun, Earth in the middle, and the moon. If you were on the Earth looking back, that's what you would see. You would see a full moon. All right, you would see the whole lit side. Now, interestingly enough, the full moon phase is the only phase when you can get a lunar eclipse, when the shadow of the Earth passes in front of the moon. That's a lunar eclipse. The only time you can get a lunar eclipse is during a full moon. So in order for a lunar eclipse to happen, it must be sun, earth, moon. All right, that's the full moon alignment. Then we continue on around to position 6. And if I turn my paper and we look as if we were on the Earth, again you see gibbous, but this is waning gibbous. Because the moon has already been full, now it's moving back towards new. So everything's going to start to get smaller. It's going to start to decrease. All right, and on around. That's first quarter. And then if we continue on around to the next position, that's the crescent. Remember, it's always pointed towards the sun. And then we get back around here, back to new. And I'll put my Earth back over here. All right? So in all the positions on your paper, 1 through 8, you've just seen what the moon looks like at those times, and you can correctly match up which of the phases are on your chart. You also have enough information to answer the question on eclipses at the bottom. All right, so to continue, the seasons on our planet are caused by the tilt of our planet. So the 22-degree angle that our planet sits at is the reason why we experience summer, fall, winter, and spring. Now, in this model right here, this is the northern hemisphere in the top, where North America and Europe and Asia are. And this is the southern hemisphere, where South America and Africa and Australia are. In this scenario, when the Earth is tilted, the top part of the Earth is tilted towards the sun, the northern hemisphere is experiencing summer. So this is the phase that we're moving into right now. The southern hemisphere is experiencing their winter at this time. So if you live in Florida, which everyone watching this video should be, and you were to get on an airplane in July when it is the hottest month in Florida, and you flew to Colombia, they would be experiencing their winter in Colombia. In fact, everywhere in South America would be experiencing their winter. So it's actually a much nicer climate down there. As the Earth revolves around the sun, this right here would be fall for us and spring for the southern hemisphere, because we are moving out of summer and they are moving out of winter. And as it continues on around here, to get to this phase, now the northern hemisphere is the one that's tilted away from the sun. So we are experiencing our winter. In the southern hemisphere, they are experiencing their summer. So if you were to go to Brazil in December, that is the hottest time that they have. So it would be nice and toasty warm. That's the perfect beach weather in Brazil. Then you come on around here, and this is us in spring and the southern hemisphere in fall, because remember, when it shifts back around over to here, we're going to be in summertime and they're going to be in wintertime. So this is, again, back to the beginning. We're in summer and they're in winter, all right? The tides on our planet are caused by a combination of interactions between the Earth, the Moon, and the Sun. Now, the sun has gravity. That gravity is pulling on the Earth. The moon also has gravity that's pulling on the Earth. The Earth is affecting both of these. The Earth's gravity causes the sun to wobble a little bit, and the Earth's gravity keeps the moon in orbit around it. All right? This is not to scale. The moon's gravity and the sun's gravity do affect the Earth. The sun, even though it's very far away, is pulling on the Earth. The moon is also pulling on the Earth. One of the effects is that the oceans bulge on the side that the moon is and on the side that the sun is. Now, at this time, this is what's called a spring tide. When the gravity of the sun is acting in combination with the gravity of the moon, we get much bigger tides than normal. It's called a spring tide. It happens twice a month. It happens during the full moon, and it happens during the new moon. Anytime the sun and the moon are acting in conjunction with each other, their gravities are additive, it's going to cause larger tides on the planet Earth. This is a neap tide. The gravity of the sun is canceled out by the effect of the gravity on the moon, so the tides are being pulled in two different directions, and therefore they're weaker at this time. So during the first quarter and during the third quarter are the neap tides, the low tides. Spring tides are the high tides, neap tides are the low tides. Again, springtime are the high tide, neap tides are the low tides. All right, so this is your walkthrough for Station 9. The seasons of the Earth are entirely caused by the tilt of the Earth, a 22.5-degree tilt. Now, there's a misconception that the seasons are caused by the Earth getting closer to and further away from the sun, but that doesn't make any sense, because when the sun is furthest away from, or when the Earth is furthest away in its elliptical orbit, it's actually the warmest, and when it's the closest in its elliptical orbit, it's actually the coolest, at least for the northern hemisphere. The seasons are caused by the tilt. Now, in this image here, you can see the northern hemisphere is tilted towards the sun, the southern hemisphere is tilted away. In this picture, it would be summertime in the northern hemisphere and wintertime in the southern hemisphere. So if we're getting ready to have summer here in Florida, if you were to get on an airplane and fly to Brazil in July, it would be wintertime in Brazil. So it would be nice and cool out. In the northern hemisphere in July, it's going to be summertime. The reverse happens in the wintertime. Here's the image of wintertime. You can see the southern hemisphere is now tilted towards the Earth and the northern hemisphere is tilted away. That is causing the northern hemisphere to experience winter and the southern hemisphere to experience summer. So in December, when it's cooler outside in Florida, if you were to fly to Brazil, that would be the time to go to the beach because it is their summertime. As the Earth rotates or spins on its axis, the surface warms up during the day and cools off at night. As the Earth rotates or spins on its axis, the daytime side of the Earth is being exposed to solar radiation and is warming up, so the surface warms up during the day, and as it rotates around, the nighttime side is losing thermal energy, so it cools off at night. Now, this image here, when you're at the beach, the Earth, the land, the sand is warming up much quicker than the ocean. So the air over the Earth, over the sand, is warming up quicker. When the air warms up, it rises. That warm air rising creates a vacuum, and so cooler air from the ocean blows in to take place. That is a constant cycle that's happening. So as that warm air rises, it cools off in the upper atmosphere and it sinks back down. It's causing a forward breeze, which is blowing you in the face. At nighttime, the reverse happens. The land cools off much quicker than the sea, so the ocean retains thermal energy. The air over the ocean is warming up and rising. The air over the land is flowing out towards the ocean to fill in that gap, and it's creating a backwards breeze. So if you're standing facing the ocean at nighttime, then the breeze is hitting you in the back of the head. All right, the energy that causes the water cycle that's evaporating the water and turning it into clouds, it all comes from the sun. Convection currents in the atmosphere are the same convection currents that are in the magma of the Earth, which we'll talk about in a couple stations. Convection currents are where something is heated from below. As it heats, it becomes less dense and it rises. And then as it gets up to the top, it cools off and it sinks back down because it becomes more dense. This is the way a lava lamp works. This is also the way the atmosphere works. You can see here in the picture, the air on the ground is warming up. It rises. As it gets to the upper atmosphere, it cools and it sinks back down. So in this, for question 8, where it says in the space below, draw a picture showing the direction that warm air flows and the direction that cool air flows, you could use this image. And lastly, the form that water will take, whether it's going to be snow or sleet or hail or rain, is going to depend upon the temperature of the air and the ground. If the air is warm and the ground is warm, it's going to come down as liquid water. If the air is cold and the ground is cold, then it's going to come down as snow. If the air is somewhere in between, or the ground is somewhere in between, that's whenever you get sleet and hail, which are the in-between forms of precipitation.